Okay, and welcome. So in this video, we're going to look at trigonometric identities. So let's dive straight in and see what that means. There are two identities that you must learn. The first one is this: tan x is equal to sine x over cos x. Now we've already seen this, but just to be clear, this is an equation here, an identity that you must learn. Okay? The second one is this: sine squared x plus cos squared x equals 1. Those are the two identities that you need to learn. So you do what you need to do to learn them, write them down every day, write them down, cover them up, recite them, whatever. You need to learn these two things. They're not given to you in the test. But the good news is, if you learn these two identities, you can solve all manner of complicated questions just by using them. And they're very, very easy marks to get if you've learnt them. Just to sort of say something about the second one, you can rearrange this equation to get sort of two extra ones. So let me just show you what I mean by that. The second one here implies that sine squared x equals 1 minus cos squared x, and that cos squared x equals 1 minus sine squared x. So just to be super duper clear, these two equations here have come from this first one. We've just rearranged the equation. So in this case, if you want to make sine squared x the subject of the equation, you would take cos squared x from this side of the equation and from this side, and that would give you this equation here. Likewise, if you start with this equation at the top and subtract sine squared x, you would get this equation here. Okay, so if you ever see a question that has 1 minus sine squared x in it, or 1 minus cos squared x, it's probably a sign that you're going to have to use one of these identities. Okay, so these are the two things you need to learn. You need to go away and learn them. And now, for the rest of the video, I'm going to do past paper question after past paper question to show you exactly how to use them. Okay, so strap yourselves in. First question here: tan x, tan squared x, cos squared x. So there's two things. There's tan x equals sine x over cos x. That's one thing that we know. And the other one that we know is going to be sine squared x plus cos squared x equals 1. Now, I don't see a 1. I don't see a sine squared x, but I do see a tan. So we're gonna use this one. Okay, just to be super clear what tan squared x actually means, tan squared x just means tan x times tan x. Yeah? And that's times cos squared x. So let's just replace the tan with this. Okay, so that's we're going to get 1 mark for writing this equation down and then for using it here. Okay, so instead of writing tan x, I'm going to write sine x over cos x times sine x over cos x times cos squared x. Okay, that's 1 mark got straight away. Oh, and my battery's running low, so I'm just going to plug that in. Right, there we go. So we've got sine x over cos x times sine x over cos x times cos squared x. Okay, let's just simplify that a little bit. Sine x times sine x would be sine squared x. Cos x times cos x would be cos squared x. And again, you might see, if I've got 2 over 3 times 3, those 3's cancel out. Okay, so 2/3 times 3 would just be 2. And again, we can cancel here. And so our final answer is just sine squared x. Okay, so we have simplified. We've taken a complicated expression, and we've made it into a nice simple one. We've simplified, and we've done so using one of our identities. Okay, so we've got to show that question. So what we're going to do for a show that question is we're going to sort of ignore this side of the equation, right? We're just going to play with this side until it ends up looking like this. So I'm hoping that the first thing you see is this 1 minus sine squared x. And we're going to remember that cos squared x is equal to 1 minus sine squared x. So this was the second identity that I taught you, and this is the rearranged version of it. So we can use that to have sine squared x over cos squared x. Okay, so I've changed this left-hand side to be sine squared x over cos squared x, and we also know that tan is equal to sine. I'll put tan x is equal to sine x over cos x, and so what that means is this would be equal to tan squared x. Okay, and actually, if we go back to the question, that's what we've been asked to show. Okay, and so for this 2-mark question, we're going to get 1 mark for writing this out here and then using it, and then we're going to get 1 mark, a second mark, for writing that out and then again using it. Okay, so this is an expand and simplify question. So you've got a bracket here. Now you guys will expand brackets however you want. I'm going to expand them in the way that I usually do it in class. Just because I think it's a bit easier to see what's going on if I do it this way. So I'm going to use the box method. You can do whatever you want. You can use FOIL. So we're doing sine x times sine x first. We're doing sine x times cos x, which we do just write like this, sine x cos x. Again, we're going to do cos x times sine x. So we're going to write that as sine x cos x, and then cos x times cos x is going to be cos squared x. So if I write that out in full, I'm going to get sine squared x plus I've written 2 sine x cos x because we've got 1 and 2. So we can just simplify that, plus cos squared x. And we know that sine squared x plus cos squared x is equal to 1. And so these 2 terms here can just be simplified to 1. So our final answer is going to be 2 sine x cos x plus 1. Again, that's just from sine squared plus cos squared is equal to 1. Okay. So quite I suppose this is fairly tricky for 2 marks. You're really getting 1 mark for the substitution, and then 1 mark for getting the whole thing correct. But of course, to do that, you need to correctly expand these brackets. So just make sure that you're quite happy, expanding brackets. The good news is there's no negatives in this question or anything like that. So I suppose it is a fairly routine expansion. Okay, we've got another prove that question. And again, alarm bell should go off. That's 1 minus sine squared a. So we know that cos squared a is equal to 1 minus sine squared a. So we can rewrite this as sine squared a over cos squared a. And we know that sine divided by cos is equal to tan. And so that implies that this over here is equal to tan squared a, which is what we've been asked to prove. Okay, you may have noticed that this question is actually identical to this question we just solved. The only difference is instead of using x, we've used a. these are all past paper questions, so that suggests to me that there's only so many questions that they can come up with. If they're reusing a question, do you understand what I mean? It's worth practicing all these past paper questions, because if they're repeating questions, there's only so many times you can get people to substitute 1 minus sine squared a into an expression. Okay, so we've got this one here. And again, I'm hoping that you're seeing 1 minus sine squared x and thinking, oh, that's cos. Yeah, we're using this. So we can write out cos cubed x over cos squared x. Okay, and if you're not too sure how to simplify this, if you think back to your index laws, if you've got 5 cubed divided by 5 squared, that's just the same as 5. Yeah, you could work that out if you wanted to verify that, but 5 cubed divided by 5 squared would be 5. So cos cubed divided by cos squared would just be cos. Okay, so our answer is cos x. Again, you're getting 1 mark for the answer, and you're getting 1 mark for the substitution, for writing this out and then actually using it here. Okay, so this is a slightly different way to ask the question. You've been told what sine x is and what cos x is, and you've been asked to find tan x. So again, we're going to write tan x is equal to sine x over cos x. Okay, it's pretty obvious which identity we need to use, because we clearly just need to use tan, because that's what we've been asked to find. And again, sine x over cos x just means sine x divided by cos x, doesn't it? That's the same idea. So if I replace sine x with 4/5 and cos x by 3/5, now it's just a case of, do you remember how to divide fractions? Well, dividing a fraction is the same as multiplying by the reciprocal. That's a posh way of saying flip over the second fraction and then make it a times. And again, I'm doing this quite quick because the point of this video is not multiplying or dividing fractions. It's using these identities and substituting it in. So if you needed help with this, look up dividing fractions. But our answer in this case would be 4/3. Right, okay, so I think this is the last one. So we'll have a quick look at this one. Again, go with your gut. Which identity do we want to use? I would suggest, because we see a tan, we should just maybe go ahead and use tan first. So that tan x is sine x over cos x. So I'm going to rewrite this out, but instead of writing tan x, I'm just going to write sine x over cos x. Right, don't panic. I can sense that you're panicking. That's fine. Right, this is all okay. I've just replaced tan x with sine x over cos x. And just, look at the numerator for a second. We've got cos x times a fraction with cos x as the denominator. This would cancel. Yeah, again, just in the same way that 5 times 2 over 5, you could cancel those 5s out. We're going to cancel the cosines out. So what we've got now is sine x over sine x. And I hope that you agree that any number divided by itself is 1. And so this rather nasty expression at the top just becomes the number 1. Much easier to deal with. Right, okay, so that's that's everything you need to know about the identities. There's only 2 to learn, and I hope that by going through some of those past paper questions, I've given you a good enough idea of how you go about answering these questions. It's a bit more of an art than like a routine skill. Whenever I see a new one of these questions, I don't just instinctively know what the correct answer is. I'm just doing my best guess. There's only two identities I can use: the tan one and the sine squared x plus cos squared x equals 1. There's only two things to choose from. So all I do is choose one of them and give it a go and see what I get. And if I get, I've not made a mistake in this video, but if I had chose the wrong one, all that I would do is at some point I think this isn't working. I'm just going to stop what I'm doing and go back to the start and try again with a different identity. So if you ever find yourself doing this and it just looks like a big mess and you don't see a way through, just try using a different identity instead. Okay, again, practice makes perfect with this sort of thing.